Hello, in today's video I'm going to be talking about dynamics, and specifically looking at Newton's first law of motion, free body diagrams, and Newton's second law of motion. So starting off with Newton's first law of motion, before I do that, I'm going to go ahead and define some key terms such as kinetic energy, which is the ability of a moving object to move another object. Acceleration is the change in velocity over time. Dynamics, or the study of forces, is what I'm going to be talking about today. So let's go ahead and get into Newton's first law of motion now. So Newton's first law of motion, which is also known as the law of inertia, states that an object will remain at rest, and an object in motion will remain in motion at a constant velocity and in a straight line unless acted upon by a net force. So some key terms to define here are inertial mass, which is the measure of an object's inertia, and inertia is the tendency of an object to resist a change in velocity. A force is a vector quantity describing the push or pull on an object. The net force can be defined as a vector, which is a vector sum of all the forces acting on an object. So now I'm going to go ahead and talk about free body diagrams. So a free body diagram is simply a representation of an object or system with a vector arrow showing all the external forces acting on it. A free body diagram is essential when analyzing and studying a system, as it shows all the forces and is a very clear method to solve a problem, used as a tool to solve a problem. So next I'm going to talk about Newton's second law of motion. So Newton's second law of motion states that a net force applied to an object changes an object's velocity. The formula for a Newton's second law of motion is sum of forces is equal to the net force, which is equal to mass times acceleration, which is equal to mass times the derivative of v. This follows a kinematic property that acceleration is equal to the derivative of velocity. Another common way of writing Newton's second law of motion is acceleration is equal to the net force divided by mass. So now that we've gotten those concepts down and clear, I'm going to go ahead and apply them to an example from a multiple choice AP exam. So I'm going to be looking at number 23, which reads, the figure above shows the directions and relative magnitudes of all three forces that are acting on an object. Which of the following best shows the direction of the object's acceleration? So I'm going to go ahead and draw the diagram. We've got force 1, force 2, and force 3. Okay. So we know that force 1 is equal to force 2 given the diagram. So force 1 is equal to force 2. And so they just cancel out. Since they cancel out, we're left with F3. And so essentially F3 is going to be in the same direction as the acceleration. So F3 is representative of the acceleration. So if we're going to draw acceleration, it should look something like this, just like F3. When we check the answer with multiple choice, we get option E. And so the response to this multiple choice question is E. Thank you.